Hello there, Algebra 1. We are going to solve our systems of equations by a process called elimination. So sometimes substitution is not the best method to use. Sometimes we want to actually go ahead and eliminate a variable. So when we eliminate a variable, we might have to, so I'm going to say if necessary, we're going to multiply our equations by a constant, also known as by a number, to make one or both of our coefficients, also known as the number before the variable, as opposite numbers. We'll say to be opposite, such as 4 and -4, 6 and -6, right? We want them to have opposite signs. Now, sometimes you don't have to do that. Sometimes you can jump right into step 2, which is that you're going to add or subtract equations, and you're going to do this step to eliminate a variable. It has to eliminate a variable. That's the only way that this works. Then you need to solve that remaining equation. And then last step is to substitute value back in and solve. Because you need to have an x and a y, right? So if you solve for your x, you need to have your y. And if you solve for your y, you need to have your x. So on this first example that we are going to work through, you are going to see all of these steps in action. All right, we're looking with the system of 3x plus 2y equals 4, and 3x minus 2y is equal to -4. Now, the first thing that I want you to notice here is that the 2y and the -2y are opposites of each other. So this is set up to go ahead and eliminate, meaning that, I'll use green, I can add up these equations, and when I add them up, the y's will disappear. So I have 3x and 3x, that's going to give me 6x. 2y plus -2y gives me 0y, or goes away, is equal to 4 plus -4, and I do need to put the 0 there because it's the other side of the equation. So this remaining equation is 6x is equal to 0. So this is now, we did number 1, we did number 2, we're on step number 3. I have to solve this, and the way I'm going to solve is divide by 6 so that x is equal to 0. Now I'm halfway there. I know that my coordinate point is 0, something. So we're now going to take this value and substitute it back in, and you can substitute anywhere that you want. I'm going to choose the top equation. It's usually just habit for me to choose that top one. It's the first one that we see. 3 times 0 is 0, leaving me with 2y equals 4. Divide by 2, y is equal to 2. So the solution to this system is the point 0, 2. Now, just to show you that you can actually do this by adding or subtracting, we're going to do it one more time, and I'm going to show you that we can subtract these. We'll choose purple this time. Actually, we'll choose orange. Little Mets colors. All right, so we're going to subtract them because if you'll notice, when you have the same coefficient, so 3x and 3x, 3x minus 3x makes those x's eliminate or disappear. So like we just said before, 3x minus 3x goes away, but you have to be very careful because you're subtracting everything here. So 2y minus negative 2y is a positive 4y, and 4 minus negative 4 is a positive 8. So now we have the equation 4y equals 8, divide by 4, y is equal to 2. We already knew that from our other one. We're just proving this to you. And now we're going to solve for x. So 3x plus 2 times 2 is equal to 4. 3x plus 4 is equal to 4. And when you're solving for x here, you get 3x equals 0, divide by 3. And we just proved the exact same thing. We already knew that this solution was the 0.02, but it's nice to know that we got it correct both times. Okay, so we didn't exactly have to do step number 1 there. So let's look at an example where you would have to multiply by something in order to set up your process for elimination. So I'm going to look at the system negative 10x plus 3y is equal to 1, and negative 5x minus 6y is equal to 23. Okay, so for me, you have 2 options here. Option number 1 is that you could go ahead and you could multiply this first equation by 2 and set up that variable as 6, or you can multiply the second equation by negative 2 and set up that variable as 10. So I'm going to choose the second one. I'm going to show you that we can multiply by a negative here to show that our negatives, we need to sometimes do that with our negative numbers. So I'm going to multiply this guy by a negative 2. So I'm just going to rewrite the first one, negative 10x plus 3y equals 1. Now in algebra, you can multiply your equations by anything as long as you multiply every single term. So negative 2 times negative 5 is 10x. Negative 2 times negative 6y is a positive 12y. And 23 times a negative 2 is a negative 46. Okay, so now that this is a negative 10 and a positive 10, when I go ahead and add these equations together, we get negative 10x plus 10x, that goes away. 3y plus 12y gives us 15y is equal to a negative 45. Now when I divide by 15, we get that y is equal to negative 3. Okay, so that was steps 1, 2, and 3. Now I got to go back, and you can actually substitute this in anywhere you want. I'm going to go ahead, I'm going to choose this top equation again. Negative 10x plus 3 times negative 3 is equal to 1. Negative 10x minus 9 is equal to 1. So we're going to add 9 on both sides. Negative 10x is equal to 10. Wow, this works out very nicely when we divide by negative 10. X is equal to a negative 1. As a reminder, you should always write your answers as a coordinate point. So this is the point, negative 1, negative 3. Then I'm going to box my answer. I'm not going to box that y equals negative 3 and x equals negative 1. We're talking about this as a coordinate point. So there's one more option, which is the fact of you might have to multiply both of your equations. So let's work through one more example here. So negative 2x minus 5y is equal to 9, and 3x plus 11y is equal to 4. And as I'm looking at these, I'm quickly going to say, okay, negative 2 and 3, there's nothing that I can multiply negative 2 by to get to 3. I can't multiply negative 11 to get to negative 5 to get to 11. So we're going to have to multiply a few things here. We're going to have to multiply our top equation by 3. So I'm going to multiply this guy by 3. so that my x's turn into negative 6x, which is a lighter green, sorry, minus 15y is equal to 27. Now I want to make my coefficient for x on this equation, I want to make it 6. So I'm going to multiply the bottom one by 2. Now this is going to set up really nicely. I get 6x plus 22y is equal to 8. And let's really go ahead. We're going to check here. The whole reason that we did this is that I have a negative 6 and a positive 6. You have two of the same coefficients. One's positive and one is negative. Let's go ahead and add these guys up. Negative 6x plus 6, that's going to go ahead and disappear. Negative 15y plus 22y is going to give us a 7y. 27 plus 8, that gets us 35. So we have the equation 7y equals 35. I'm going to solve for y by dividing by 7. Y is equal to 5. Halfway there. You can choose any problem that you want, any one that you want. I'm going to go ahead, again, I always kind of choose this top one just to keep things consistent. I'm solving for x, so I need to substitute this 5 in for y is equal to 9. If you're confused as to where I got that equation, right here, 2x minus 5y equals 9. All right, now we have negative 2x, negative 5 times 5 is negative 25. Now I can add 25 to both sides. Negative 2x is equal to 34. So we're going to go ahead and divide by a negative 2. And x is equal to a negative, that's 17. So now my solution to this one is the point negative 17, 5. And that is our elimination method for solving systems of equations.